Welcome back to lesson 4. So this lesson is called Define Quadrilaterals, and it is a bit of a doozy. So buckle in. So the toughest thing about defining quadrilaterals is that some shapes, a quadrilateral is a four-sided shape. And some quadrilaterals have like very specific requirements to define them as that shape. And then others are very broad. And so it can get a little bit confusing, and some shapes can be recognized as two different kinds of quadrilaterals and they overlap a little bit, and that's okay. So we're gonna go through it, we're gonna do our best, we're gonna learn about quadrilaterals, we're gonna feel totally awesome about it, and I'm super stoked for you guys. It's gonna be great. So here we go. Page 503. Oh, I lost my book. Here it is. Page 503, the I can statement says, I can use the number of sides, this is important, the number of sides, the number of angles, the number of sides of equal lengths, and the number of right angles to describe and identify quadrilaterals. So those are the key requirements when we are defining quadrilaterals. We're looking at side lengths, we're looking at parallel sides, we're looking at the number of right angles. And yeah, that's it. So I'm excited. Okay, the Spark Your Learning says, Misty is making a sign for the Green Star Mountain Climbing Club. The club has asked for a sign that is a four-sided polygon with exactly two right angles. So a polygon is a shape, we learned this a couple lessons ago. A polygon is a closed shape made up of line segments, so not a curved path, no roundness. And then if it's a four-sided polygon, it's a quadrilateral. So let's draw a polygon that Misty could use. So exactly two right angles. Remember, a right angle makes a perfect square. Use a corner of a paper to think about that. So first of all, I'm going to draw my two right angles first. Just get that out of the way. And so I'm going to draw something like this and go across. So that's my first right angle. Obviously it has to connect because a polygon is a closed shape. So I'm going to keep going. And then I'm going to go straight up. And that's my second right angle. So now I got my two right angles, got that out of the way. Now what I do not want to do is connect right across the top, because that's going to give me two more right angles. And I don't want four right angles, I only want two. And I have my two, so I have to come up with something else. So I'm gonna make one side longer, so that in order to connect the two sides, I have to go at a diagonal. And if I have a diagonal, I will not have a right angle. So that's my trick. Whoa, going all the way down. Okay, there you go. There's my sign. Ta-da! Next page. Okay, this is where it gets crazy. Ah! Your amygdala might be going, oh my gosh, so many things. So many things on the page, we can't do it. We got it. Okay. How can you use attributes to name and identify quadrilaterals? Circle all the attributes the shapes share. So, we are going to circle everything that all of these shapes share. We have a rectangle. We've got I don't know what that is. It looks like a paper airplane. We got a trapezoid. We got a rhombus. We got a parallelogram. We got another kind of trapezoid. Multiple trapezoids. We got a square. So all of these have 4 sides. 1, 2, 3, 4, 1, 2, 3, 4. So we're going to circle that. All of these have 4 sides. And because they have 4 sides, they have 4 angles. Now, do they have 4 right angles? No. Look at this one. This angle is way bigger than 90 degrees. This one is way smaller. This one is not that big, but this one has a right angle. But not all of them have 4 right angles, so they do not have that in common. Do they have 2 pairs of opposite sides of equal length? 2 pairs. Nope, this one, definitely none of the sides are equal on that one. So actually, that's not a trapezoid. That's just a quadrilateral. Do they have 4 sides of equal length? Nope. That one's shorter, longer. They're not all equal. Do they have at least 1 pair of parallel sides? None of these ones are parallel. None of those ones are parallel. So, no. So the only thing that these have in common is that they are 4 sides and 4 angles. So this is very broad, right? All the requirements is that you have to have 4 sides and you have to have 4 angles, and you are a quadrilateral. That's it. That's the definition. Okay, so let's dig a little deeper. What do all of these shapes have in common? Do they have 4 sides? Yes. Do they have 4 angles? Yes. Do they have 4 right angles? Nope, I'm seeing some curves. So no, they do not have 4 right angles. Do they have 2 pairs of opposite sides of equal length? Okay, so we have 2 pairs of opposite sides of equal length. No, they don't, because those are the same, but those are not. Those are the same, so that one is. That one doesn't work. Or this one does work, but this one doesn't work. So no, not that one. Do they have at least 1 pair of parallel sides? Oh wait, did I skip one? 4 sides of equal length. Nope. Nope. Do they have at least 1 pair of parallel sides? Those are parallel. Those are parallel. Those are parallel. Parallel, parallel. Parallel, 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 parallel. So yes, those have at least 1 pair of parallel sides. Do they have 2 pairs of parallel sides? So this one does, this one does, that one does. This one does not, and this one does not. So no. So again, digging a tiny bit deeper, the only requirement for being a trapezoid is that you have 4 sides, 4 angles, and you have at least 1 pair of parallel sides. Okay, this next one is going to blow your mind. Okay, so the 4 sides, yes. 4 angles, yes. 4 right angles, nope. This one's slanted, so nope. 2 pairs of opposite sides of equal length. So 2 pairs, meaning these 2 are in the same length and those ones are the same length. These 2 same length, these 2 same length. These same. Now this one, oh, did you even see that? Hopefully you did. This one, this top line is not the same length as the side, and that's okay because the pairs are the left and right and the top and bottom. So that's what we're looking for. So those are same, these are same. So yes, there are 2 pairs of opposite sides of equal length. Do they have 4 sides of equal length? No, because this rectangle, that's where it's important, where like this length is not equal to that length. So no, not 4 sides of equal length. Do they have 2 pairs, oh, at least, sorry, I skipped it. At least 1 pair of parallel sides? Yes. Do they have 2 pairs of parallel sides? Yes, it does. The sides are parallel to each other. The top and bottom are parallel to each other in all of these shapes, which is why they're called parallelograms. Get it? Parallel. parallelogram because there's two sets of parallel sides. Is a parallelogram a trapezoid? Yes. Is a trapezoid necessarily a parallelogram? No. And that is what's going to blow your mind in this lesson. It's crazy. It's crazy. It's crazy. But it's okay. Okay, so let me pause. The reason I say that is because look at, if we go to trapezoids, right here, that's a parallelogram because they have two pairs of parallel sides. This is a parallelogram because they have two pairs of parallel sides. This is a parallelogram because it has two pairs of parallel sides. Now, is this trapezoid a parallelogram? No, because it does not have two parallel sets. So this top and bottom are not parallel to each other. So that's why it's just a trapezoid. But this right here is a trapezoid and a parallelogram. But this can only be classified as a trapezoid because it doesn't have two sets of parallel sides. And that is what is so neat. Okay, next page. These are rectangles. Do we have four sides? Yes. Do we have four angles? Yes. Do we have four right angles? Yes. Do we have two pairs of opposite sides of equal length? Yes. Do we have four sides of equal length? No. We got small, small, big, big. So no. Do we have at least one pair of parallel sides? Yes. Do we have two pairs of parallel sides? Yes. So this is a rectangle, so a little bit more specific, right? You have to have all of these attributes in order to be a rectangle. Do you have to have four sides of equal length? No. We're getting to that. Okay, so here we go. Is a rectangle a parallelogram? Yes. Are parallelograms rectangles? Sometimes, not always. This is a rectangle and it's a parallelogram. This is a parallelogram, but it's not a rectangle because it does not have four right angles. And one of the requirements for being a rectangle is having four right angles. It's so crazy. Okay. Part E. These are squares. Do they have four sides? Yes. Do they have four angles? Yes. Do they have four right angles? Yes. Do they have two pairs of opposite sides of equal length? Yes. Do they have four sides of equal length? Yes. Do they have at least one pair of parallel sides? Yes. Do they have two pairs of parallel sides? Yes. Okay, so we have to check off every single one of these attributes in order to be a square. So that is like super tough, super specific. So can a rectangle, okay, can a square be a rectangle? Yes. Can a rectangle be a square? Not always. See the situation that we're getting ourselves in? Okay, it's a lot. Part F. These are rhombuses. Do they have four sides? Ah! Dropping everything. Okay, do they have four sides? Yes. Do they have four angles? Yes. Do they have four right angles? Nope. Look at this one. Super tiny, super big. Not a right angle. Do they have two pairs of opposite sides of equal length? Yes. Do they have four sides of equal length? Oh my gosh. Yes, they do. Yes, they do. I had to think for a minute. I'm going to double check. Yes, they do. Yes, four sides of equal length. Do they have at least one pair of parallel sides? Yes. Do they have two pairs of parallel sides? Yes. The only difference between a square and a rhombus is that a square has to have four right angles. A rhombus does not. It has to have everything else, but it does not have to have four right angles. Is a square a rhombus? Yes. Is a rhombus a square? Sometimes. It's amazing. Okay. Number 1, write the letters that match the shape. What? Oh, okay. This is gonna be good. So we have to say what's a rectangle, a rhombus, a quadrilateral, a parallelogram, a trapezoid, and a square. Now, right off the bat, all of these shapes have 4 sides, right? So they are all going to be a quadrilateral. The only defining attribute for a quadrilateral is that it has to have 4 sides and 4 angles. All of these shapes meet that requirement. Okay, so all 3. Now, the next one is a trapezoid. The only requirement for being a trapezoid is that you have 4 sides, 4 angles, and at least 1 pair of parallel sides. So do all these shapes have at least 1 pair of parallel sides? Yes. So they are all considered trapezoids. Okay. Wild, I know. So then let's go to the next. I'm starting with like the broadest description, and I'm going down to like the narrowest description. So broadest being quadrilaterals, next we have trapezoids, then we have parallelograms. Now with parallelograms, remember we had to have 2 pairs of parallel sides. So that's what makes them different from a trapezoid. Trapezoid, you only have 1 parallel, 2 sets. So which one can be a parallelogram? Not C, because those sides are not parallel to each other. So only A and B can be a parallelogram. Okay, and then the rectangle, let's see, what's the next one? Yeah, rectangle, not C, but a rectangle. A square is considered a rectangle. So both A and B are rectangles. Now let's go to a square. Now the only square here is B, because A, not all the sides are the same on A. And then the only rhombus is also B, because a square can also be a rhombus. So neat, right? Now you would not go to this and say that's a trapezoid. Okay, even though you're technically correct, we use the most specific category to label our shapes, just to like make it more understandable. We would not come to this and be like, oh, that's a quadrilateral. It's like, okay, yeah, I know it's a quadrilateral. Be more specific. Same with this one. Oh, that's a parallelogram. Oops. Oh, that's a parallelogram. It's like, okay, yes, but is it a square? Is it a rhombus? We want to be as specific as possible. So we have all these categories to keep everything straight. But yeah, we want to be as specific as possible. So I guess that's all I'll say about that. Last page, it says, Max sees a polygon in his classroom. This polygon has 4 sides and 4 angles. All the angles are right angles. Circle all the shapes this polygon could be. So the defining characteristics, 4 sides, 4 angles, that's all quadrilaterals. All the angles, here's where it gets tricky, all the angles are right angles. Let's see. Define a trapezoid as a quadrilateral that has exactly 1 pair of parallel sides. Oh, okay, I get that. Okay, so circle all the shapes the polygon could be. A rectangle. Could it be a rectangle? Yes. Okay, because rectangles have 4 sides and 4 angles, and all the angles are right angles. Could it be a rhombus? Yes, if the rhombus had right angles. So it could be a rhombus. Now remember, a rhombus does not have to have right angles, but if it does have right angles, Great. A triangle. No, a triangle has 3 sides, so that is out. Hexagon. No, hexagon has 6 sides. That's out. A square. Yes, a square has 4 sides, 4 angles, and all the angles are right angles. What about a trapezoid? Now, a trapezoid, this is where this little piece comes in. Define a trapezoid as a quadrilateral that has exactly 1 pair of parallel sides. So since it only has 1, the other 2 are going to be moving out or in, making those angles not right angles. So not a trapezoid. What additional attribute would make the polygon a square? So we have 4 sides, we have 4 angles, all the angles are right angles. What else would make it a square? Well, all the sides have to be the same length. Same length. All right, circle all the words that describe the quadrilateral. This shape here, okay, is it a rectangle? No, because it does not have 2 sets of sides that are equal in length. In fact, none of the sides are equal in length. Is it a rhombus? No. Is it a square? No, definitely not. Is it a quadrilateral? Yes. So we have to be very broad with this one because it has 4 sides and 4 angles. You're a quadrilateral. But it doesn't have anything else, so it can't be anything more specific. Number 4. So is this a parallelogram? Yes, because it has 2 sets of parallel sides. Is this a rectangle? Yes, because there are 2 sets of sides that are equal in length. Is it a square? No, because the sides are not all equal. Is it a rhombus? No, because the sides are not all equal. Number 5. Is this a parallelogram? No, because a parallelogram has to have 2 sets of parallel sides. The top and bottom are parallel. Left and right sides are not parallel. See how this one goes at an angle? So not a parallelogram. Is this a trapezoid? Yes, because it has 4 sides and it only has 1 set of parallel lines, and that's all we need. Is it a square? No. Is it a rectangle? No. Okay. Write all or some to complete the sentences. Blank, the sides of a square are equal in length. Some or all? All. All the sides of a square are equal in length. Number 7. Blank rhombuses are squares. Some. Some rhombuses are squares. Blank sides of a rectangle are of equal length. That again would be some, right? The 2 pairs. Blank squares are rectangles. Some, no, all. Yeah, all squares are rectangles because they have 2 pairs of equal sides. They all happen to be equal, but to be a rectangle, you only need 2 pairs, 2 sets of equal length sides. Crazy! Okay, so all squares are rectangles. Who knew? Who knew? Okay, you guys, we did it. 1 more lesson to go. It's actually gonna be super short because it's a review. Whew, you guys did amazing. I know this is like mind-blowing. It's super cool though. So I hope you enjoyed that. Good luck on your homework. Take a break. Go run a lap outside, and then come back to the review, and then you're done with math for the day, except for the end of the year assessment. Keep working on that. Okay, love your guts. Bye.